In this video, we're going to determine when Newton's method does not work. It says using Newton's method, try to find a root for f of x equals this cubic using an initial approximation of x0 equal 7. Which of the following statements describes what happens? So Newton's method is x to the n plus, or x sub n plus 1 is equal to x sub n minus f of x sub n over f prime of x sub n. So I'm going to take the derivative of this function right away because we're going to need it. And we bring the 3 to the front, that cancels the 1/3, we get x squared. Bring the 2 to the front, that cancels the denominator, we get minus 15x. Derivative of 36x is 36. So now we're going to plug these equations. We want to plug these equations into this calculator so that this makes the whole process easier. So we're going to say 1/3 x cubed minus 15 over 2 x squared plus 36x plus 607 over 6. That's the original function. Now we're going to plug in the derivative, x squared minus 15x plus 36. And x sub 0 is 7, so we're going to write this as x sub 0 plus 1 is equal to x sub 0 minus f of x sub 0 over f prime of x sub 0. So what we're doing here is we're plugging in what x sub 0 is. So we have 7 minus f of 7 over f prime of 7. So that's what we need to plug in the calculator is 7 stores x, and then we need to plug that into the original function, which gives us 100. So f of 7 is equal to 100, and f prime of 7 is going to be equal to, grab the derivative, negative 20. So we end up with 7 minus 100 over negative 20, which when you subtract those, you're going to get, that'll be negative 5. So you have 7 minus negative 5, which is positive 12. So that's x1. So now we're going to do x2. So x sub 1 plus 1 is equal to x sub 1 minus f of x sub 1 over f prime of x sub 1, which would be 12 minus f of 12 over f prime of 12. So I'm going to start plugging in what f of 12 is and what's f prime of 12. So we're going to say 12, store it as x. Grab the original. I get 175 over 6. Grab the derivative. I get 0. So this is 12 minus, let's get 175 over 6 as a decimal. It's 29.1667 divided by 0. Uh-oh. Can't happen. We're dividing by 0. So if we look at our options here, it says at one of the approximations x sub n, we have f prime x sub n equals 0. That happened. F prime of 12 equals 0. But f of x n is not equal to 0. So the numerator is not equal to 0. So this is just describing that we have a situation where this can't happen. So that's where Newton's method fails.